All right. So today we did a lot of number systems. We just kind of went through and did mostly definitions. So number systems, there's different kinds. We first have natural numbers. These are regular whole numbers, one and up. Just think about counting. These are numbers you naturally account in the real world. If I'm counting students, for example, I'm not going to start at zero. I'm going to start at one for the first student. Whole numbers are exactly the same as natural numbers, but it includes zero. So whole numbers is zero, and then one, two, three, four, five, six, seven. Integers, these are negative and positive whole numbers and zero. So integers, these are negative one, negative two, negative five, plus one, two, three, and zero. So all those are integers. There is more. After that, we took notes on what a rational number is. A rational number, these are all numbers, positive or negative, that can be rewritten as a fraction. That last part is the important part. Rational numbers can be converted into fractions. So, like any whole number can be written as a fraction, any decimal can be written as a fraction, as long as it is a terminating decimal, meaning it stops at some point, or if it's a repeating decimal. Otherwise, it would be an irrational number. An irrational number is any number that cannot be written as a fraction. Usually, these are an imperfect square or an infinite non repeating decimal. So these are things like pi, for example, would be irrational, or like square root of 3. And that's going to be more or less all of the real numbers. All of those would be considered real numbers. Anything else, that's going to be considered unreal numbers, but we don't get into that this year. We also talked about, right here is where I mentioned a decimal that does not repeat is terminating. A decimal that is repeating is just called a repeating decimal. And then I gave a quick refresher course on how to convert a repeating decimal into a fraction. Because repeating decimals can be converted into a fraction. For example, 0.7 repeating, you would simply set that equal to the numerator would have whichever digit is repeating. In this case, the 7 is repeating. So we would put the 7 as the numerator, and we would set an equal number of 9s as the denominator. So 7/9 would be about 0.7 repeating. Or if I have, for whatever reason, a decimal that repeated as 0.423423423, and it just repeated like that, I would set the 4, 2, and the 3 as the numerator. I would set 3 9s as the denominator. So that is how converting a repeating decimal would work. Otherwise, I just verbally reminded students of the lessons from 5th and 6th grade about converting from fraction to a decimal. Fraction to a decimal, all you do is divide the numerator by the denominator. That's all you do. So to get back to this, we would just do 7 divided by 9, and that should give me 0.7 repeating. And that is going to be it. That's all we really did. The homework for the night was more or less a puzzle worksheet that went through these definitions and scenarios. So that is it. This should be enough to get you caught up. So good luck.